this video is going to look specifically at ionic compounds and how you should be showing what an ionic compound is. Okay, remember, an ionic compound is made up of a metal and a nonmetal. Okay, the metal is always going to lose electrons. The nonmetal is always going to gain electrons. So the metals are always going to be positive. The nonmetals are always going to be negative. Okay, so the first thing that you're going to have to do in each case is look at what the elements are and how many valence electrons they have. Okay, so if we look at beryllium, it's in group 2. So it has 2 valence electrons. All right, if we look at sulfur, it is in group 16, so it has 6 valence electrons. Okay, so what's going to happen in an ionic bond? Beryllium is the metal. It's going to give its electrons to sulfur. So it can donate an electron here, and it can donate an electron here. Okay, so if I rewrite that, what I have is I have beryllium, and it has lost 2 electrons, which makes it positive 2. And I have sulfur. Sulfur has gained 2 electrons, which makes it a negative 2. So it only takes 1 beryllium and 1 sulfur to combine to form an ionic compound. All right. Let's look at B, potassium and fluorine. Okay, so potassium is in group 1, 1 valence electron. Fluorine is in group 17, so it has 7 valence electrons. Okay, so what's going to happen is potassium is going to donate its electron to fluorine. Now, these first 2 examples have been awesome because it takes 1 of each element. Okay, so if I draw this out, potassium has lost an electron, so it has a +1 charge. And fluorine has gained an electron, so now it has 8 valence electrons. Remember, that's the goal. Every atom wants to get to 8 valence electrons. So it's going to have a -1 charge. Okay, this is the answer that I need to see from you. Okay, if you get to the point that you can do these without showing the electrons going where they're going, that's fine. And you should get to that point because you should see some things that are happening. The metal is always giving up all of its electrons. The nonmetal is always getting a full octet of 8 electrons. Okay, so if we think about that, we should be able to kind of get to a point we can do this without really having to draw it all out. But I'm gonna go ahead and show you a few more of these. So hydrogen and sulfur. Now, this is a problem, right? Because hydrogen is a nonmetal, so is sulfur. The problem is with hydrogen, sometimes hydrogen behaves like a nonmetal, but oftentimes hydrogen, because it's in group 1 with those alkali metals, it behaves like a metal. So in this case, hydrogen is going to behave like a metal. It's going to give away its electrons. Okay, so if you look, hydrogen has 1 valence electron. It's in group 1. Sulfur has 6 valence electrons. Okay, now hydrogen needs to give away its electron. It only has 1, so it's going to donate 1 electron to sulfur. But sulfur needs to get to that full octet, so it's going to take 2 hydrogens to react with 1 sulfur. Okay, and what's going to happen, what we're going to have in the end is we're going to have hydrogen with a +1 charge, and we can simplify that, and we can just say that we have 2 of those. Okay, we don't have to draw them all out. And then sulfur, I'm going to show it with its 8 valence electrons. And since it gained 2 electrons, it's going to have a charge of -2, because it gained electrons. Okay, so this is the answer that I'll need to see. Okay, now let's look at aluminum and chlorine. If you remember, in class on Thursday, I believe, we talked briefly about how, I'm going to pull up my periodic table here. Okay, we talked about everything in group 1 wants to lose an electron. Okay, so everything in group 1 is going to form a +1 ion. Everything in group 2 has 2 valence electrons. It wants to lose 2 valence electrons, so it would have a charge of +2. We skip the middle, all right? Group 13 has 3 valence electrons. It's going to want to give away those 3 valence electrons, okay? It would have a +3 charge. Carbon is mostly covalent bonding, so we're not going to talk about that group 14. Group 15 have 5 valence electrons. They want to gain 3, which would give them a -3 charge. Group 16 has 6 valence electrons. It would want to gain 2, giving it a -2 charge. And then finally, group 17 has 7 valence electrons. It's going to form -1 ions. Okay, so if you think about that, okay, when I go to do this, when I look at aluminum, I can look at my periodic table and I can see that aluminum is right here in group 13. That tells me aluminum has 3 valence electrons, okay? It also tells me that it's going to form a +3 ion. So I'm going to show you a trick here. So if aluminum forms a +3 ion, okay, that means it got rid of 3 electrons. Chlorine over here, if you look, chlorine is right here. It's in group 17, meaning it has 7 valence electrons. It wants to take 1. And when it takes an electron, it's going to form a -1 ion. Okay, and in order to do that, it would have to have 8 valence electrons. Now, here's the trick. How many chlorine do I need to react with 1 aluminum? Okay, the way you figure that out is our charges need to balance. So if aluminum has a +3 charge and chlorine has a -1, you know what it's going to take? It's going to take 3 chlorines to react with 1 aluminum. Okay, so now without doing this whole process of drawing out where the electrons start and where they end up, you've written a Lewis dot structure. Let's try that a couple more times, okay? So iodine in this case, iodine is in group 17, okay? So it's got 7 valence electrons. Notice that iodine is the nonmetal. So iodine is going to receive or take 1 electron, which is going to give it 8. It's in group 17, so it's going to form a -1 ion. Sodium is over here in group 1, meaning it's got 1 valence electron. It's going to form a +1 ion. Check it out. We're done. Sodium's +1, iodine's -1. Okay, so it takes 1 of each. Let's look at selenium and strontium. Okay, just so we kind of finish this idea. Again, strontium is the metal, selenium is the nonmetal. Okay, so if I look, strontium is in group 2. What that means is that strontium wants to give away 2 electrons and form a +2 ion. Okay, just by looking at where it is on the periodic table, we can figure that out. Selenium is over here in group 16, which means it wants to take 2 electrons. So selenium is going to end up with a -2 charge and 8 electrons. We can't forget all of the electrons. All right. Now, once again, check it out. Strontium's +2, selenium's -2. It only takes 1 of each of those to form an ionic compound. All right. Let's look at gallium and oxygen. All right. Gallium, where is gallium? Gallium is over here in group 13. That means gallium has 3 valence electrons that it wants to get rid of. So if gallium gives away all of its electrons, it's going to form a +3 charge. Okay, and remember, you can figure that out if you remember the charges of each group. Okay, oxygen, on the other hand, is in group 16, okay? Group 16 wants to receive 2 electrons and form a -2 ion. I'm going to draw all these electrons around, okay? Now, this is the trickiest one you'll see. You've got gallium that's +3, oxygen that's -2. So we need to get those charges to balance out. So we need the least common factor. And in this case, it's going to be 6. So I can put my brackets around here, and I can say it's going to take 2 gallium and how many oxygen? 3 oxygen to, let's make that a little neater, 3 oxygen to make a neutral compound. So the purpose of this video is kind of to show you it's important to know where the electrons come from and where they go, okay? But you can do this process without having to write all of that out if you know the charges and the ions that they're going to form, all right? So I hope that helped, and I will see you in class.